Hello and welcome to the next part of our GDL Bible. It is part 5, and in this part we will show you how to use different commands for 3D objects in GDL, except block and cylinder, which we already used. I will show you a more complex command, which is the prism, and different variations of it, and how to use status codes. So let's start. Let's first hide all toolbars, and then we will create a new object. And let's type NL here. Description. We will create a simple, let's say, what shall we create? Let's create a simple chair. Simple chair using prisms and status codes. Alright, in the parameters we will define our parameters. First, let's show you how to group the parameters. We select this type of parameter, which is a title, heading, and here we will type dimensions. And in the parameters that you want to be grouped in the group dimensions, you will have to assign this thing in front of them and type the name of the parameters. Let's say first the legs dimensions, leg A, which will be the leg length, and leg B, which will be the leg width, and the leg shape. The leg of the chair has its shape, rectangular or cylindrical. Let's again create a boolean parameter, which will be cylindrical leg, yes or no. If it is on, the legs will be cylindrical, and if it's off, the legs will be rectangular. And since when the legs are cylindrical, we will need only one dimension, in this case leg A, I will lock the other dimension, and I will show you how to do it. Go to the parameter script, parameter script, and type if leg shape, in this case the boolean parameter, leg shape, is equal to 1, which means is turned on, and the legs are cylindrical, then lock the parameter leg B. And we will type the other group, which will be materials. LMAT, which will be not this one. LMAT will be the legs material. And SMAT will be seating material. Seat material. Alright, the seat material will be let's say wood pine, just to show you the difference, and the legs will be wood 1. In the dimensions, we will define two more parameters, which will be SH, which will be seat height, and BH will be back height. And let's fill the parameters. First, the A will be the total A dimension of the chair will be 50 centimeters, dimension to 50 centimeters, height including back support will be 65, or let's make it a high backed chair. And leg A will be 6 by here 6 by 4. Rectangular seed height will be 42. Back height. Actually, back height is not needed in this case, but I will change it to seed thickness, because back height will be the total height. Seed thickness will be, let's say, 4 centimeters. And let's again use the parameter script for the first time by typing the restrictions of the parameters. We will use the command values, which restricts the certain parameter. Let's restrict the total seat height, which cannot exceed the total height of the chair. Per seat height, range, you type range, it is two values between which the parameters has to hold its value. In this case, I will not type the first value, let's say 0 to z, z, y, z, x. Therefore, the sh parameter cannot exceed z, z, y, z, x. And again, for the leg A, we'll restrict it not to exceed 1/10 of the total chair length, or let's say 1/8, which is 0.125 multiplied to A, 0 to this value. And the same for leg B. And if I've done everything right, let's check. LA, yes, it is leg A. Alright. And as you can see, a small note showed up here. The value is between 0 and 6.3, which is 0.125 multiplied by this value. And if I type, let's say, 20, it will restrict it back to the maximum value, which is 6.3. That's the purpose of it. And let's get going in the 3D script. First, let's show you the commands we will use. In the 3D shapes, we will use this command, PRISM. It is a simple command. First, we will use its and the number of nodes, h, the height of the prism, and x1, y1, and x and z, yn are the node coordinates. These nodes have x and y coordinates, and the prism is generally an object which is a polyline in the xy plane, and it is extruded perpendicularly of the value h. It is the total height. This is the first and the simplest prism we will use. And now let's proceed. The legs will be 4 legs, and first, as mentioned in the previous video, we will divide it in subroutines. The first subroutine will be goes up 1, legs, leg, and 1 leg. I will say 1 leg, and I will show you how to goes up 2, all legs, goes up 11, which will be points 4. No, it will be seat. Goes up 21, will be back. It will be very simple indeed, this object, but it is very useful to know how to do it. And here are our subroutine 1, return, 2, return, 11, return, and 21, return. And since this subroutine 1 will create one leg, I will use it in subroutine 2 for creating the separate legs. And in subroutine 1 we will create one leg, which will be prism, and you type the legs. Just prism and use the coordinates of the legs. In this case will be the dimensions leg A and leg B. And let's type the dimensions. As you see in the prism command, we will just type four nodes, which will be 0, 0, 0 leg A, leg B, 0 leg B, and we will return to the first node. So let's do it. Prism, 4 nodes, the height will be seed height minus seed thickness, and the nodes 0, 0, 0 leg B, leg A, leg B, and leg A, 0. Alright, this is the prism, and we will just define the material here, material, leg, or L, net. Alright, and now the second subroutine will call this one and create the separate legs in the positions that are specified for each leg. And let's go. First we will create the first leg, and we will type another as off, which will be seed offset around legs, and that means the seed will be overlapping the legs of this from this value. It cannot exceed, of course, certain limits, but for the sake of this exercise I will type 5 centimeters. And let's go. We have first to create the first leg, goes up 1, then we'll move the cursor at A. First we'll add the offset, seed off 0, then we'll add A minus this one, and add A minus seed off 0, and minus leg A, of course, and again goes up 1. I defined it in subroutine 1 not to have type every time this command. It will save me some code space. Del 1, and again add A minus S of minus leg A, B minus S of minus leg, not a leg A, but seed off, leg B in this case, 0, and goes up 1, del 1, and again do this, but we will add only seed offset along the x-axis, and again goes up 1 and del 1. As you can see, we have 3 groups of commands. Each will call this prism and create the leg. Let's see what we've done. First check. Alright. Yes, as expected, we have the 4 legs of the chair, and we will have, of course, to build the seat above them. It will be the 11th subroutine. We will create the seat, and I will show you the advanced way of using the prism command, which is with status codes. Status codes are these values here, S1 and Sn. For viewing what status codes are, they are specific parameters which define how the edges are represented. If we use these values, we will represent a certain
visibility of each edge, and by using increase values by 100 plus these values, 200, 300, and we can define tangents, curves, and tangential curves, and so on. But for this exercise we will use the simplest status codes, which I suggest to use, the 15 status code, which will enable all edge visibility. And let's see, it's not as difficult as it seems to be. First we will have to go to the prism again. First let's move the cursor, add Z, in this case seat height minus seat thickness. And again we will use the prism, but in this case we type this character for the prism with status codes. And as you can see, it's the same syntaxis really, but you will have just to type the status codes, like S1, Sn, and we will have again 4 values, 4 nodes, 4, the height will be S thickness, and the values themselves will be 0, 0, and 15. 15 is the status code of the selected node, which means the visibility will be full, like in here, maximum visibility. A 0, 15, A B 15, and 0 B 15. And if you want to close the polygon, basically it's not needed in this case, because as you can see we have rectangular shape. It's not needed to close the polygon, but if you want to close it, you will have to type the first node, and the status code is -1 if you want to build a hole in it. But in this case we don't need that. I just show you for the sake of this exercise. And of course we will have to change the material seat matte, and delete the add command we used here. And that's about it. That will create the seat, if I've done everything right. Yes, here it is. As you can see, the material of the seat is different. Of course it's not aesthetic this way, but I showed you how to use different materials. You can of course change the material to the first one. You have more options that way. And that's it. It's of the same wood as used for the legs. And I will reduce the offset to 2 centimeters. Yes. And now we will create the back by using the same routine with the prism. I will copy what I've done here, add sh, and the prism will be zzYzh minus sh, which will be the remainder of the height. And the coordinates, let's say here we have back B, which will be the back thickness. It will be the same as the leg thickness, and I will use 4 centimeters. And let's use it. In this case we use let's say 0 B no, we'll use the X value will be the total length of the back support, and we'll use 0 A and 0, that's alright. And for the other values, 0 0 A0 the thickness of the thing. Let's say b minus this value. Let's say b minus back b, and here we will increase this value by back b, which will amount to the total b amount. And material will be the same as the seat material. Again, delete the transformation. Alright, we have minus sh, minus sh is alright, like b, it's alright. Aha, zz, yz, x. Perfect. And let's see what we've done. And that's it, that's the back of the chair. It's very primitive, but it's obviously a chair. And you can, of course, change 45, and the chair will decrease in size. If you increase this drastically, it will be a very long chair, like a small bed, but let's not make abnormal chairs as of now. And now let's create the options for the cylindrical leg. We will have to switch in the the subroutine one, where we type the points of the legs. We will have to switch to points with status codes as shown in the other subroutine, which will allow us to use different type of prism. If leg shape is equal to 0, then the legs will be rectangular. And else, which means if leg shape is 1, we'll use the same prism but with different status codes. And that's why prism is the most used 3D command, because you can easily change its shape. You will not have to switch the command or the syntax of the command. We will need two nodes, the same height, 0, 0, and here we will use the status code for center, this one, set center point, 900. And we will say 0, 0, let's say not 0, but leg A multiplied by 0.5, because we will have to get to the center of the leg. And here 900 plus 15. And to create a full circle we will use the 4000 status code, which is full circle using center point and radius. We have already created our center point, and the radius is defined here with the first parameter. I will keep it for it to be visible during the command, if it's possible at all. No, it's not. Alright, let's say the radius is leg A multiplied by 0.5. Here we type the angle, 360 degrees, and here 4000 as mentioned. And yes, two parameters needed. Here we have 4, alright, 15, 15, 15. We will have to switch to the other type of prism, of course. And be careful with the commas when you insert them. And let's see the result. Here, since leg shape is cylindrical, we will have to switch it to leg shape is rectangular. By going on, legs will obviously turn to cylinders. And it's very useful to know this way to do it. And the last thing I will mention in this video is the different variety of prism, which will add some chamfering and curving of the prism. In this case, for the seat, we'll use this type of prism, F prism. It, as you can see, it uses the same amount of nodes, but from a certain height onward, it will chamfer or fillet the surface. We'll use that for the seat. Let's say the hue height is the half of the total height, seat thickness. The angle is 45 degrees, and we'll create it. Let's go to the seat subroutine and change it to F prism. As you can see, we have the syntax: top material, bottom material, side material, hue material. All of them will use that SMAT, and I will type it: SMAT, 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 SMAT. And on the next row we have number of nodes, which is again 4, thickness, which again I typed as thickness, and angle and hue height. Angle is 45 degrees, and hue height will be as thickness multiplied by 0.5. If hue height is if angle is 0 degrees, it will just fillet and not chamfer the ending. We have to type, of course, all commas. Alright, and let's see the result. And obviously it is chamfered by 45 degrees. If you want it to be different angle, we will use, let's see, we'll use 75 degrees. And it changes its angle, of course. If you want it to be filleted, you will have to use the angle of 0 degrees. And it's a perfect fillet. And it's very useful because it's the simplest way to do it. You just created a very complex 3D object by just using a simple prism command. So thanks for watching. This was part 5 of our series, and I wish you much success and enjoyment in your work.